Hello guys, my name is Aaron, and in this video we're going to be talking about linked lists. Linked list is a completely different type of data structure than array. When we saw arrays, the first thing that we noticed is that data was stored sequentially. The items were one next to the other. But with linked list, this is not the case. The data is all spread through memory. You have chunks of data in completely different places. And what we do is we link them together using a pointer so that each element contains a pointer telling us where the next element is. This means we can dynamically insert data, we can remove data, we don't need to worry about space like in arrays, we don't need to worry about how much we can fit into our linked list because they are dynamically allocated, and using pointers you know exactly where the next item is. So the idea here is to show you how the algorithm for inserting new elements in the linked list works, which is also the same algorithm for traversing any linked list. So we're going to start out with an empty linked list. An empty linked list contains, we only have a pointer for a linked list, one pointer which points to the very first element of the linked list. Because each element will have its own pointer to the next element, we only need to care about handling the first element, the pointer to the first element. In this case, when the linked list is empty, this pointer will be pointing to null, or whatever your programming language uses to mark as unused. So we want to insert that data. We want to use this algorithm, which works as follows. We have two local variables. Prev will contain a pointer to the element that we have iterated previously, the element that is before our current element, and we have our current element, which is node. Prev is initialized to null because there is no element previous to the very first element, and node is initialized to the very first element of the linked list. And what we do is, while the current element is not null, we're going to be iterating through the next element, making it node be its next element. Node equals node.next, which means we're going to be iterating through the pointers until we reach the end of our list. And by the time we reach the end of our list, our variable prev will be pointing to the very last element in our list. So we can insert a new node, and we can point that new node in the last node's next pointer. So let's see how this works. We want to insert 5. We initialize prev to null, and we initialize node to LL. While node different from null, LL is pointing right now to null. LL is pointing to null, so we do not execute the while loop, and we now have to do this. Prev.next equals new node. In this case, prev is null, so when prev is null, we know that we're at the beginning of our linked list, and we know that there is no element, so instead of doing prev.next, we just create a new element. We create a new node, insert the data, which is 5, and that's it, and we make our linked list point to that very first element that we just inserted. Now, to insert the 4, we execute the code again, prev is initialized to null, node is initialized to the very beginning, which is pointing to 5. We evaluate the while condition. Node is different from null, node is different from null, so we execute the code within the while loop, and the code says that now prev equals node, so I have to update the value of prev and make it equal to that of node. And node equals node next pointer. So we look at the next pointer of our current element of node. Node is pointing to 5. We look at the next pointer and we store that value in node. The next pointer here is null, so this will be null. We reiterate. While node different from null, node is now equal to null, so we do not execute the while loop, and now we can do the actual insertion. We look at prev. Prev is pointing to 5, and it's telling us to make a new node and link prev.next with this new node. So we create the new node with value 4, which is the data we're inserting, and we're gonna link the previous node with this one. And this one is linked to null. Now we want to insert -3. We execute the code again. Prev equals null. Node equals the beginning of the linked list, in this case it's 5. While node different from null, node is different from null, so we execute the while loop. Prev equals node. Prev is equals 5. Node equals node next. The next to the 5 is 4, so node will now point to the node that contains 4. We reevaluate the while loop. Node different from null, node is different from null, so we do prev equals null, and node equals node next. The next pointer to this node is a null. There is no element beyond this node. So we reevaluate the condition node different from null, node is equal to node, so we don't execute the while loop. We can now proceed to the actual insertion. We create a new node containing the data we want to insert, which is -3. This new node's next pointer points to nothing, and we make prev.next, we make the next pointer of our prev element. Prev is 4, so its next pointer will now point to the newly created node. Alright, now we want to insert 8. We want to insert 8. We do the same thing again. Prev equals null, and node equals the beginning of the linked list. This is 5. We do the while loop. While node different from null, node is different from null. Prev equals node. Prev now equals 5. Node equals node dot next. The next one to the 5 is 4. Node is different from null, so we do the same thing again. Prev equals node. Prev is now 4. Node equals node next. Next one to the 4 is -3. We redo the check, node different from null, so we do the same thing again. Prev equals node. Node equals node dot next. The next one to -3 is null. Node this time equals null, so we don't execute the while loop, and now we create the new node that will contain number 8, and we link our prev with the new node. Alright, so this would be insertion. Now, how do we delete an item from a linked list? Well, we kind of do the same thing, except now we need to know the index. So for example, if this is 0, 1, 2, 3, let's say I want to delete number 2, this node over here. So what we're going to do is, instead of doing this code here for insertion, we're going to do it for deletion. And we're going to add another condition to the while loop, and this condition will be while index bigger than 0. In other words, and we're going to do index, we're going to decrement it inside the while loop. In other words, we're going to be counting how many iterations we are doing until we reach the node that we want to delete. So let's say that we want to delete node 2, so I equals 2. Prev equals node, prev equals null. Node equals the beginning of our linked list, which is 5. So we do while node different from null and I is bigger than 0, prev equals node, prev now equals 5. Node equals node next, which is 4. And we decrement our counter, I is now 1. We go back to the evaluation of the while loop. Node different from null, node is different from null, and I bigger than 0, I is bigger than 0. So we do prev equals node, prev now equals node, 4. And node equals node next, the next element to the 4 is minus 3. And we decrement I, so now I is 0, and we reevaluate the condition. Well, node different from null, node is different from null, and I is bigger than 0. I is not bigger than 0, I is now 0, so we do not execute the while loop. So in what condition are we now? Well, we have prev pointing to the element that is previous to the element that we want to delete. We want to delete this one right here. And of course, node is pointing to the node that we want to delete. So how do we delete a node from a linked list? We now have the pointer to the previous one and the pointer to the current one. How do we delete this one, the current node? How do we delete it? Well, the idea is simple. What we're going to do is, because linked lists work by starting from the very first and going and using the pointers to find the next element, what we're going to do is we're going to modify this pointer over here so that instead of pointing to the element that we want to delete, we're going to make it point to the element right next to it. So we're going to move this pointer here to here. This way, when we reach to this node's next pointer will not point to the node that we have just deleted. It will point to the next one. Will point to the 8. So what we'll do is prev dot next equals node dot next. So we make this pointer, instead of going to this node, we're going to make it go to the next one. We'll make it go here. and we can safely delete this node from existence, and our linked list still works. So that's how you insert and delete from linked list. This is more or less the structure for pretty much any operation that involves linked lists. Doing a lookup, searching in a linked list, is the same as this, but instead of doing whatever operation you do here, you just return the data inside the current node. So basically, this is the structure for navigating through a linked list, and once you have done navigating to where you want to go, either the end of the list or a specific node, if you use this counter here, whatever, you just do whatever you want to do with node and prev here. You want to insert a new item, you can insert a new item. If you want to insert a new item between this node and this node, you can do it. If you want to delete or obtain or whatever. So this will be for linked list. In the next video, I'm going to be talking about stacks and queues that are easily implemented using linked list. Hope to see you soon.